Hello folks, welcome to the third session of the geometry series. In this episode, we are going to talk about circles. Now circles is a pretty interesting topic. It's quite easy as well. There are a handful of concepts and if we understand them correctly, we can pretty much take any of the questions, right? So let's get going. So what is a circle to begin with? Circle is again a two-dimensional figure, right? Like a square or triangle or rectangle, correct? Now, what is that which makes something as a circle? If every point on that figure is equidistant from a particular point, then that figure becomes a circle. So basically in this diagram, let's say we have the center O and every point on this figure, whether it's point A or point B or point C, that is equidistant from the center O, and hence this is a circle. This distance between center and any point on the circle is called as the radius, right? So as we see, radius is the only attribute which governs the size of the circle, right? The smaller the radius, the smaller the circle, the bigger the radius, the bigger the circle, right? So what are those concepts, right? The first one is the circumference, which is nothing but the perimeter or the boundary of the circle, and it is given by 2 pi r, where pi is a constant. The value of pi typically which we take is 3.14, right? So 2 times pi times radius will give us the boundary of the circle. So, right? So if we know the radius, we can find the circumference or vice versa. Let's go to the area. Again, area would also be determined by the radius. The smaller the radius, the smaller the area, the bigger the radius, the bigger the area. And the area of a circle is given by pi r squared, right? Pi times r. Again, if we know the radius, then we can find the area, or if we know the area, we can find the radius and vice versa. Okay. So these are the two very common and very basic things which we pretty much all are aware of. The third thing here is that in this diagram, for example, we have the center O, and these are the 2 points A and B on the circle, right? So this is kind of an arc. So AB is an arc, and let's say that the length of this arc AB is L, okay? So what we are saying in point number 3 is that the ratio of the arc to the center angle remains the same, right? So the bigger the arc, the bigger the central angle. So in this case, angle AOB or angle BOA is the center angle. Let's say if I were to increase the length of AB, suppose I were to increase the length of this arc and this was B dash here, right? Then obviously the central angle would have been larger by this angle, right? So again, just to reiterate, the ratio of the length of the arc to the central angle remains the same. So partial length, partial angle, full length is nothing but the circumference which we just talked about, and the full angle would be 360 degrees. So L over theta is equal to 2 pi r over 360 degrees, correct? And we will see more of this as we take up the questions. Okay, so let's say that we extend this line OB further so that it cuts the circle again at a point, let's say C. Okay, now BC is nothing but called as the diameter of a circle. So what's the diameter of a circle? A diameter of a circle is any line which passes through the center of the circle and cuts the circle, touches the circle at the two end points. So that line segment is called as the diameter. In this case, BC will be the diameter of the circle. Obviously, diameter is twice the radius because OB is radius and OC will also be radius. So the whole diameter would be twice of radius, right? So kind of a simple thing here, D is equal to 2R, and diameter is typically denoted by D. Okay. Now one important thing here. So any diameter of a circle will cut the circle into two equal halves or two semicircles, right? And any triangle which we draw in a semicircle would be a right angle triangle and 90-degree triangles. What I mean by that is that in this semicircle portion, right? This is semicircle portion. If I draw any triangle, let's say this triangle, this angle would be 90 degrees. If I draw another triangle, let's say this, it will again be a 90 degree, right? So any triangle within the semicircle is a right angle triangle or a 90-degree triangle. Then that's an important thing for us to know, because once we have right angle triangle into picture, we can use any trig functions, we can use Pythagoras theorem and things like that. So that's an important thing, right? So let's say I can mark it as point number 4, that triangle within a semicircle is right angle triangle. Okay, so please keep that in mind. The only other thing which I want to quickly talk about is the tangent. Okay, what is a tangent? A tangent is a line segment which is drawn from any point outside the circle and which touches the circle exactly at one point, right? That is called as a tangent. For example, let's say I have a point here, okay, and let's say this point is T, and I draw a line which is touching the circle exactly at one point, let's say like this, and suppose it touches at C, okay. So CT is a tangent to this circle because it touches the circle exactly at one point, okay. The point to note is that any tangent will always be 90 degrees to the radius. So in this case, OC will be 90 degrees to CT. So this angle will always be 90 degrees, right? So the point where it touches, where the tangent touches the circle, if we join that point with the center, right, basically the radius, that radius would be 90 degrees to the tangent, okay? So tangent is always 90 degrees to the respective radius, okay? Okay, so just to quickly reiterate, right, point number one, circumference or the perimeter is 2 pi r. The area of the circle is pi r square. The ratio of the length of the arc to the central angle goes in the same proportion, right? So partial length, partial angle, full length, full angle. So L over theta is equal to 2 pi r over 360 degrees. The fourth point is that any triangle within a semicircle is always 90-degree triangle or a right angle triangle. And the fifth point is that tangent, any tangent is always 90 degrees or perpendicular to the respective radius. Let's now take up some questions. We have a circle with center O. The area of the circle is given to be as 100 pi. PQ is the tangent to the circle. The length of RQ is 16. So this length here is 16. Okay, and we have to find the length of PQ, right? So let's get started, right? The area is given as 100 pi. We know that the area of the circle is given by pi r square. So it means that we can very quickly find the value of r, the radius of the circle, right? So pi r square is equal to 100 pi, right? We have to find r, so we divide by pi here, we divide by pi this side. Pi gets cancelled. We get r square is equal to 100, r is equal to 10. I mean, basically we take the square root on both the sides, we get the radius is 10. So it means that this length OR is 10, the length OP is also 10, but they're all radius, right? Now PQ is the tangent to the circle, and we just discussed earlier that any tangent is always 90 degrees to the respective radius, right? So if PQ is the tangent, then PQ will form a 90 degree with the radius, with OP. So this angle is essentially 90 degree angle. So essentially we're talking about a right angle triangle here, and if we look closely, we have this side 10, we have the total side 10 plus 16, which is 26. We can use the Pythagoras theorem to find the length of PQ. Let's say that the length of PQ is x, right? So by the Pythagoras theorem, we will say x square plus 10 square is equal to OQ square, which is 26 square, right? X square plus 100 is equal to 26 square. 26 square is nothing but 676, right? So 676, we get x square is equal to 676 minus 100, which is 576. We take the square root on both the sides, and we get x is equal to 24. So PQ is 24. Okay, let's go ahead with another question here. So we have this circle with center O. The radius of the circle is given to be as 27. So OA is 27, or OB is also 27. And the central angle which is formed by this arc is 40 degrees. Okay. The length of arc AB is given to be as k pi. And we have to find the value of k, right? So again, as we discussed earlier, right, the ratio of the arc length to the central angle remains the same, right? So partial length of the arc, partial angle, full length, full angle, right? So essentially the length of AB, which is k pi, over the central angle which it's forming, which is 40 degree in this case, is equal to the ratio of the full length, which is 2 pi r, r is 27, divided by the full central angle. So this is what we have. Partial length, partial angle, full length, full angle, right? And we solve this to get the value of k. Essentially, pi and pi get cancelled. We can do cross multiplication. So we get 360 times k is equal to 2 times 27 times 40. We divide by 360 on both sides, right, to get the value of k. And we get the value of k as 6, right? So again, just to repeat, we had this arc AB, the length of arc AB is given as k pi, the central angle which this arc is forming is 40 degrees, the radius is 27, and we had to find the value of k. We're just using the same point which we discussed earlier, that the ratio of the arc length to the central angle remains the same, and then we solve that to get the value of k. Okay, let's take another question here. So we have a circle with center O, and the length of OS is equal to 9 units. The length of PQ is 7 units, and we have to find the area of OPQR. Okay. Now OT is perpendicular to OS, right? This angle is also 90 degree. So essentially, this is 1/4 of the circle, right? So we're talking about a rectangle within a quarter of a circle, and in this situation, we have to find the area of the rectangle OPQR, right? So OS is equal to 9, and OS is nothing but the radius, right? So OS is 9, and OT obviously would also be 9, right? Now to find the area of the rectangle OPQR, all we got to do is to find the length and the width, because the area of a rectangle is length times width. PQ is already given to be 7, so this is 7. All we got to do is to find this length, and once we find this length, the area of this rectangle would be 7 times this side, right? So what we can do is that we can draw this radius, basically join the points O and Q. Now if we see OQ is also the radius, right? And the radius is 9, hence OQ is 9, correct? This length is 9, and this is a right angle triangle. So this is 7, so this is also 7. So if we look at this triangle here, this is O, this is Q, this is R, this side is 7, and this side is 9. So this is nothing but the hypotenuse, right? So we can use the Pythagoras theorem to find the length of QR. Let's say the length of QR is x, right? As per the Pythagoras theorem, we will have x square plus 7 square, which is 49, is equal to 9 square, which is 81. So x square is equal to 81 minus 49, which will be equal to 32, right? So the length of x would be square root of 32, right? So this is square root of 32. Hence the area of OPQR would be 7 times square root of 32. Square root of 32 we can factor as 16 times 2. Square root of 16 comes out as 4. So it becomes 7 times 4 times root 2, or 28 root 2. So 28 root 2 is the area of the rectangle OPQR. So we have this semicircle, PQ is the diameter, and hence this is a semicircle. We have different arc lengths here. This is A, this one is A plus 1, this is A plus 2, A plus 3, and A plus 4, and so on, right? So we have these 5 different arc lengths here. This angle over here is 42 degrees, okay? So this is the given information, and we have to find the value of A, right? So as we discussed earlier, right, the arc lengths go in the same ratio as the central angle, or in other words, the ratio of the arc length to the central angle remains the same. The smaller the arc, the smaller the central angle, the bigger the arc, the bigger the central angle, correct? So we're going to use that here. So essentially this arc length to this angle would be the total arc length to this total angle. And since this is a semicircle or this is a straight line, this overall angle would be 180 degrees, right? So a plus 4 divided by 42 degrees, right? This ratio is going to be the same as the total arc length. So we're going to add all the arc lengths. So a plus 1 plus a plus 2 plus a plus 3 plus a plus 4. So we get 5a plus 10, right? So 5a plus 10 divided by 180 degrees, right? Because the total arc length to the total angle is equal to this small arc length to the small angle. So we're going to use this and we can find the value of a, right? So it's a single fraction on the left and single fraction on the right. So we can do the cross multiplication here. So 180 times a plus 4 is equal to 42 times 5a plus 10, right? So 180a plus 720 is equal to 210a plus 420. We can bring this a this side, so it will be 210 minus 180a, which is 30a, and we can get 420 on this side, which will be 720 minus 420, which is 300, right? Divide by 30 on both sides, and we get the value of a as 10. So the value of a is 10. Again, just to quickly reiterate, all we are saying is that the ratio of the arc length to the central angle made by that arc, right? So if this is the arc, this arc length to this angle will be the same as this arc length to the overall angle. Okay, let's take one last question here. So we have this circle with center O. PQ is the diameter, right, passing through the center of the circle, and RS is the chord, right? What is chord? Chord is any line segment within the circle which is touching 2 points on the circle and not passing through the center. When a chord passes through the center, it is called as a diameter, right? So RS is this chord and PQ is the diameter, and the distance between the chord and the diameter is given to be 2 root 7. When they say distance, it means that the shortest distance or the 90-degree distance. So this distance is 2 root 7, okay? And RS is 3/4 of PQ, okay? So the chord's length is 3/4 of the diameter's length. So these are the few things given, and we have to find the radius of the circle, right? So one thing which we need to understand, or which we need to know here, is that whenever we draw a perpendicular from the center of the circle to any chord, it will bisect the chord into 2 equal halves. So here in this case, right, this is the center of the circle and we are drawing a perpendicular from the center of the circle to this chord, so it will bisect the chord into 2 equal parts. So this part would be equal to this part. So let's say that this point is T. So RT would be equal to ST, right? Why? Because it's a perpendicular drawn from the center to the chord, okay? So now if we look at this, right, essentially, let's say that this side is X, right? RT is X, so TS would also be X, okay? What they've given is that 2X, or basically RS, is equal to 3/4 of the diameter. Diameter is nothing but 2R, because let's say this is R and this is R, so it's 2R, so 3/4 of 2R. So this is the relation given between the chord and the diameter. 2 and 2 cancel out, so we get X is equal to 3/4 of R. Okay, we'll see why we are doing this. Now, if we join these 2 points, right, this becomes the radius of the circle, right, from the center to this point in the circle, so this is also R. So let me draw this triangle here. This is T, this is R, and this is O. OR is nothing but the radius, let's say R. OT is given to us as 2 root 7, right, and RT is nothing but x, and we just found that x is 3/4 of r. So this length is 3/4 of r, correct? So we have got the dimensions of this right angle triangle in terms of r. We can use the Pythagoras theorem to solve for r. So what does the Pythagoras theorem say? Square of this side plus the square of this side is equal to the square of hypotenuse. So square of this, so 2√7 square plus square of this, 3/4 r square is equal to hypotenuse square, which is r square, right? We can expand this. This is 4 times 7, so it's 28 plus 9/16 r square is equal to r square, right? You get this to the other side, so we get r square minus 9/16 r square, which is nothing but 7/16 r square, right? So essentially we got 7/16 r square is equal to 28, right? We can do cross multiplication. We get 7r square is equal to 16 times 28. We divide by 7 on both sides. We get r square is equal to 16 times 4 is 64. Take the square root on both the sides and we get r is equal to 8, right? So the radius of the circle is 8. Just to quickly reiterate, what we did was that we used the property that when we drop the perpendicular from the center to the chord, it's a 90 degree. So this becomes a right angle triangle. This side is already given to us as 2√7. We wrote this side also in terms of r. This is already r. Hence we were able to use the Pythagoras theorem and solve for r. Hopefully you guys liked the video and it gave you a good perspective in terms of the different aspects which come into picture when we deal with circles. In case of any questions, please do feel free to reach out to us at info.mathletes@gmail.com. See you in the next session.